Okay, so now we've made the IK for this, what we can actually do is mirror it across. So like we did before, select the top joint, go to skeleton, mirror joints, and we're going to set this to behavior, and the reason why is because we want the same rotation, we want that x-axis facing down these bones as it was before. So I'll just hit apply. We can see it's mirrored across the IK. So first thing I'm going to do is open up the outliner, and I'm going to re-put this IK into the IK group, just so everything's in its place. And the joints, we can see it's already put them in the bound joints group. So one thing I want to double check is if we select the hierarchy and display the local rotative axes of both these joint chains, we can see that it's pointing down the x-axis, so down the bone is x, which is the same on both sides, apart from it's on this side it's negative x, but it's still facing down that bone, which is what we want. But we can see that it's inverted the y and the z. So what it's actually doing is the whole axis has been rotated 180 degrees. So what we can do here is a couple of things. We can try use the joint orient tool, so orient joint, reset settings, and try reuse that. But we can see that because we've got an IK in there, it's going to sort of screw things about. We could try delete the IK and redo that, but we don't really want to delete the IK because the whole reason we kept that in there. So what I'm actually going to do is just go back into component mode, go to the question mark, which is miscellaneous items, so we can select these pivots, these local rotative axes. I'm just going to go through and select each one of these, and all we will really want to do is we basically just want to rotate these around. So we can see that if we rotated across x 180 degrees, so y was facing up, z will be pointing forward again. So this is another case where mel becomes quite handy just as a little tool. So using the rotate tool, it's going to be quite awkward to try and do this by eye, try and get it so it's 180 degrees. And we could set some settings like to snap to 180 degrees, but it's a lot easier to just type out the rotate command. So we'll just hit rotate. So all I'm doing down here in the bottom left is it's the command line where we can just input certain mel commands. So here we're working with mel. So if it says Python, we can just click it so it says mel, so we know we're typing in mel commands. I'll just type in rotate -r for relative, so it's a mel flag, which basically means it's going to take the orientation of these joints and just add 180 degrees. And we want to rotate it 180 degrees in the x. So it goes x, y, z, so 180 for x. Then for y we want 0, and z we want 0. And just enter. And we can see how now all these axes are facing the correct way. So y is pointing up, z is pointing straight forward. And all the x's are aligned with the bones, and the z is still aligned with these hinges of the fingers. And we can move that IK around just to check so everything's working fine. So reselect the hierarchy just to take off the local rotative axis because we don't need to see it anymore. And we could just show the mesh and just check. So I know this character is symmetrical, but it always helps to just double check things. So checking where these joints are placed on the elbow, and especially the fingers. So just checking everything's in order. And what we can do now is just hit Control D. Now a good way to, well actually we'll mirror the controls over in a sec, because we can mirror across the polevector controls as well as the wrist controls both together. So I'm going to go ahead and start making the polevector control. So in the curves I'm just going to double click the nub circle tool and reset the tool, and I'm just going to hold down V and vert snap onto this joint here. I'm just going to rotate this 90 degrees and showing the mesh, just move this back into place. So as we were saying earlier with the RP, the rotate plane IK, this is going to be the third point, so you can start to see this sort of visual triangle. So going from the shoulder to the wrist to the polevector and back is going to form that triangle, what we're going to use. So I'll delete the history, freeze transformations on that again. So what I'm actually going to do here is select both the curve and the joint that we snapped it from. So we snapped it to this joint here, the elbow joint, and moved it back. I'm just going to hit local rotative axes again. And what I want to do is, what I was on about earlier in the character node, these extra nodes to show, I want to create a control curve that goes from this control to the elbow. And this is just a curve that's referenced, so the animator can't select it, they can't edit it, but it's there just to show that, for instance, if this control went inside the snail's shell, if they wanted it to be there, there's still a line coming from the elbow to the control, so the animator knows where the control is. So it's just really easy to see where the controls are. So all we're going to do is get the EP curve tool, make sure it's on linear, and I'm just going to hold down V to vert snap. And because we displayed the local rotative axis, we can actually vert snap to that. So we'll vert snap to the local rotative axis of that joint, of that curve, sorry. So now I'm just going to hit Control Vertex, so right click, Control Vertex, and hold down C, which is curve snap. And in this Z axis, I'm just going to snap it to this curve. So all I'm doing there is selecting the Z axis, so I'm only moving in the Z axis, holding down C for curve snap, and then just middle mouse clicking and wiggling on this curve. So it's going to snap it to that curve. So what we need now is we need these two ends of the CVs, two ends of the curve, to be controlled to move with these two objects. So to do that, what we can do is Control Vertex, select. So I'm going to change my selection mask, so we're just working with the curve. So I can select this CV without selecting the joints, and I'm just going to go to Create Deformers and Cluster. And I'm going to do the same for this back CV here. So now we've got two clusters, and the idea is that basically, and I'll turn a few more selection masks on so we can get these clusters selected. Basically this cluster is now controlling that CV, so wherever the cluster goes, the CV goes. So if these clusters are connected to the curve and the elbow joint, this line, this curve in the middle, is going to follow along with these two. So open up the outliner again, and we'll start renaming these. So we'll start with the wrist, which we did earlier, and I'm just going to type CC for control curve underscore L underscore wrist underscore O1. Copy the name, paste it at the back, and I'm just going to call this left arm PV for polevector. Copy the name, and I'm going to call this left arm PV for polevector, and display. So this is just going to be for the polevector, but just to display it, just as a visual aid. And actually, I'm going to call this cluster CLS for cluster. Left PV display underscore 01, because there's two of these. I'm just going to say this A, and I'm going to rename this one B. So what we can do here now is I'm going to start mirroring this across. So selecting these three curves, I'm just going to hit Control D to duplicate them, Control G to group them. Because group creates its pivot in the origin, this basically means I know that the character's based on the origin, so I can just add a -1 to the scale, and this is just going to flip it over. So this avoids us needing to move each individual thing over and rescaling it or removing all these CVs. And all I can do now is just select them in the outliner, hit Shift P to unparent, delete the group we made because we just made it to mirror it across, and we'll just delete history, freeze transformations. And I'll quickly do the same over here. Create deformer cluster, and selecting the last CV, just hit G to repeat the last tool or last command, which was the cluster. And again, rename these now, and just rename it the right. And it can be seen a bit tedious going through all these, renaming them, but this is sort of the boring side of rigging. You've got to go through and make sure it's all named correctly, but later on, you know, a few days later, if you come back to this rig a few days down the line, or even a few hours, you might see these clusters, and if they're just called cluster 1, 2 and 3, you'll have no idea what they were for, and you'll have to go digging through your rig again just to find out what they were. But just renaming them at the start, we just know what they are. Right, make sure I rename that B. Okay, so I'll just hide the local rotative axes on these joints and curves. So in the next lesson we're just going to constrain these up so we can start to move these elements and see everything connected together.